going. All right. All right. Section 2.8. We're just going to do, this section is kind of titled Functions and Operations with Functions. So it's pretty much everything that we've done already. I mean, we've done evaluating, and a lot of this is evaluating. So let's look at this part. It says find this. We're going to find this. This is a function f, and this is a function g. Do you see, once again, this is function f right here, and this is function g. I want you to see there's f and there's g. We're going to subtract the two functions because there's a subtraction sign. Before we subtract the two functions, f minus g with this parentheses 1 is the same thing as saying f to the 1 minus g to the 1. G parentheses 1. Can somebody tell me what does the 1 signify in this parentheses? What does the 1 signify? What does it mean? What's that 1 mean in that parentheses? Look right here. Whatever's in that parentheses is the x value. It's really important that we understand when we're dealing with functions, there's always a letter and then parentheses and then a number in it. In that parentheses is what x equals. X equals 1 in both of these cases. X equals 1. Do you see? We're going to subtract the two functions, but we're putting 1 in both of those functions. We're putting 1 into the x value. Okay, so that's what this says. We're putting 1 in the x value. So function f is right here. And I'm going to write it as f is 3x squared plus 3. Do you see? Function f is 3x squared plus 3. And I'm going to put the whole function f in a big bracket because you got to do all that function f work. Then we're going to subtract. And we're going to do function g stuff. G is x plus 6. Everywhere there's an x, I put a parentheses. X plus 6. Now, we're putting 1 into the x spot for each. We're putting 1 into the x spot for each. And then we're going to do the math. This side, you end up, when you put this in your calculator, you end up with 6. This side, when you put this, just the stuff inside the brackets, you end up with 7. So the answer is 6 minus 7, which is -1. So when I subtract the two functions and x equals 1, my answer is -1. Okay? Just want to make sure we got that. If not, we got the next one. We're going to go through the process again. And this is really, oh, by the way, I was going to say it's really similar to evaluate. It says evaluate in the instructions. And if you remember what I said, evaluate means is plug numbers into letters. And then do the math. We're plugging this number 1 into the x's. And then we're going to subtract the 2. Okay, let's try the next one. Here we have the two functions adding together. So I'm going to put it up here. We have function f, and we're going to plug -1 into x. And then we're going to add it with function g, and we're going to plug -1 into x. That's what this means here. We're going to add the two functions, but we're going to plug negative into each one. So function f is this down here. We're not doing number 1. We're doing number 2 now. F is x plus 3. I will put it in brackets because it's all separate. And g is x plus 6. And in the x, we're plugging in negative 1. Negative 1. And then we're going to do the math. Negative 1 plus 3 is 2. Negative 1 plus 6 is 5. 2 plus 5 is 7. That's our answer. F plus G, when you plug negative 1 into X, you get an answer of 7. You get a Y. Do you remember? Do you see this is the X and this is the Y? The answer is the Y. Everybody okay so far? We only have 13 of these. Doing different operations with functions. So far we've subtracted, we've added. Let's see what else we have. Is this microphone on? You guys are so bad. You're so quiet. There we go. Somebody said something in the chat box. All right. Number 3. Can somebody tell me what number 3, what are we doing? What are the two functions doing?
Dividing.
Yes, dividing. So we have, and so this is how I set it up. I have function f with negative 3 in it, and I have function g with negative 3 in it, and we're going to divide the two. On top, function f is 2x minus 2. Function g on the bottom is 2x squared plus 14x plus 5. Everywhere there's a letter, I put a parentheses because I'm going to plug in the number, and we're plugging negative 3 into every x spot. Okay, so do the math on top. If you put just the top in your calculator, you get negative 8. If you put the bottom in your calculator, I have no idea what you get. Let's see, 18. I think I get negative 19. Anybody else put that bottom in their calculator?
Yeah, it's negative 19.
Yeah, I wrote negative 18 though. It's negative 19, yes. So this is the answer. However, you can't have two negatives in an answer. Negative divided by negative is a positive. So the answer is 18 or 8 over 19, and it doesn't reduce. Negative divided by negative is a positive. 18 over 9 on my calculator, when you use the correct calculator, it doesn't reduce. It stays as 18 over 9. I checked out some of the grades for test 3. I looked at all the grades, and so far everybody's passed. It looks good. You guys are doing well. Really well. Surprisingly well. Question number 4. Here I have two functions multiplying. So I'm going to have function f with negative 4 in it, and then I'm going to multiply function g with negative 4 in it. First, we're going to put down function f. F is just x minus 1, and g is 5x squared plus 19x minus 3. And we're plugging negative 4 into everything. Negative 4 here, negative 4 here, and negative 4 here. When I do the math, -4 minus 1 is -5. On this side, I think I'm going to have to put that in my calculator again. This is a 4. It looks like a 9. Okay. Da, da, da. And I get 1.
Yeah, I got 1 too.
Good. So if I get 5 for this, -5 for that, and I get 1 for this, I got to multiply the two. -5 times 1 is -5, and that's my answer. When I multiply the two functions and I put -4 into the x value, my answer is -5. Good. So far, so good? Okay. All right. Question 5. Now, this is a little different than all the rest, but it's really similar. It's a little different, but it's similar. It says find this, but there's no number. We don't have a number in there. So we're finding f when we don't put anything in it, and then we're going to subtract g when we don't put anything in it. F is 9x minus 5, subtract. G is 5x minus 4. And do you see it's really important that I group the function f and I group the function g, because we have to subtract these two. That's it. We're not plugging a number in. We're just going to subtract. Can somebody tell me when I subtract these two, what's the first thing I have to do? Everybody should be able to tell me this. What's the first thing I do with this now? I have to subtract the two.
You combine like terms?
Close, but there's something before that. Close.
Do you have to factor it?
No, there's no factoring. We just have to find the answer. Like she says, we got to combine like terms. But before we combine like terms, you have to take the stuff out of the parentheses. How do you take it out of the parentheses? What's the word I'm looking for?
FOIL?
No, FOIL is when you multiply two things. We're subtracting. Boy, we really forget. I think we learned this on the first week. You have to distribute a -1. If there's a negative in front of a parentheses, you have to distribute. It's really important. And if there's this parentheses, there's a +1 in front of this. When you distribute a +1, nothing changes. This is 9x minus 5. However, when you distribute a -1, -1 times 5x is a -5x. -1 times a -4 is a +4. So once you distribute, then the parentheses disappear. Now you combine like terms, add apples with apples and bananas with bananas. 9x minus 5x. 9 minus 5 is 4x. A -5 and a +4 on my calculator, -5 plus 4 gives me a -1. This is my answer. If I take these two functions and don't put nothing in it, just leave x there, I get 4x minus 1. Don't forget, if there's a negative in front of the parentheses, it's as though there's a -1 and you have to distribute it. If there's nothing in front of the parentheses, nothing changes. It's like you're distributing just a +1. Nothing changes. But once you distribute, the parentheses disappear. Okay. It's Wednesday. Boy, week is going by fast. Luckily, you're not in a 5-week class. Tomorrow's the last day for the 5-week classes. And that was a fast class. Number 6. It's not going faster than you thought. All right. What are you saying? I really dragged this course out. Oh. All right, number 6. I'm trying to start number 6. We're going to add these two functions together, but we're not plugging anything into the x. Do you see? We're going to add them, but we're not plugging anything in. We're going to take f and just leave x there, and then we're going to take g and just leave x there and add it together. F is 2x plus 5. We're going to do this separately. G is 4 over x minus 2. And by the way, since there's nothing in front of the 2x plus 5, you actually don't need the parentheses there because you're distributing a 1 and nothing changes. Can I add these two together? You can only add fractions with common denominators. The stuff on the left doesn't have a denominator. By the way, I can't add 2x. I cannot add 2x with 4 plus x minus 2. Even though there's x here, I can only add 2 x's with other x's like 3x, not where there's an x on the bottom like that. So those can't be added. This is my answer. That's it. Can somebody look in the back of the book and verify? There's a little bit more. We have to state the domain, but that's the answer. There's nothing else we need to do for that, I think. Is that the answer in the back? Uh-oh.
Yeah, that's the answer.
Okay, so we're going to state the domain. Domain is what can x equal, and x can equal anything we want it to equal, except there's one number that x is not allowed to equal. Out of all the numbers, there's only one number x cannot equal. Can somebody tell me that number? There's one number that x cannot equal.
2.
2. Thank you very much. She said 2 because if I put a 2 down here, 2 minus 2 on the bottom is 0. Put 4 divided by 0 in your calculator, it says error. You can't have 0 on the bottom of a fraction. I can put 7 in there. I won't get 0. I can put 9, -8, -2. Doesn't matter what I put in there. I will get an answer. The only number I won't get an answer for is 2. So when you look at the domain, the rational function, the bottom cannot equal 0. So if I put a 2 in there, that equals 0. So the domain is x cannot equal 2. Now, that's one way of writing it. I'm not sure how they write it in the back of the book. I'm assuming it's an interval notation because everything else was interval notation. And it's, in other words, x can equal everything, -infinity, but it can't equal 2. And then we're going to start up on the other side of 2 and go to infinity. So this is how you say x can equal everything, but not 2. Remember, we put parentheses saying it gets really close to 2. It doesn't equal 2. Then it jumps over on the other side of 2 and continues on to infinity. But it doesn't equal 2. So this is how you would say that. Okay. Number 7. This is going too fast. I feel like I'm going way too fast. Let me know if anybody needs me to slow down, if anybody's taking notes. Number 7. Number 7 says we're going to multiply the two functions. So we're going to take function f and multiply it with function g. And we're not putting a number in it. So f is the square root of 3x plus 2. G is the square root of 6x minus 3. Now you got to remember a square root rule. I don't remember us doing this, but let me just show you. The square root of 2 times the square root of 2. If you have two square roots multiplied together, you can squeeze them together and multiply them together on the inside. Since they're both on the inside, you can squeeze it together. Square root of 2 times 2 is the square root of 4, and then the square root of 4 is just 2. It comes out as a 2. So you can, when you have square roots, you can squeeze them together and multiply. So that's what we're going to do here. We're going to squeeze these two together. And I have 3x plus 2 times 6x minus 3. Do you see? We have two square roots and I'm squeezing them together. I put them in parentheses because they're each one separate. So, and now somebody had said a word before. What do we do now? Somebody had mentioned the word for the other problem, but what do we do now? What word is it?
FOIL.
FOIL, there we go. When you multiply two terms times two terms, you use FOIL. 3x times 6x is 18x squared. Remember, 3 times 6 is 18. X times x is x squared. 3x times a negative 3 is a negative 9x. 2 times 6x is a positive 12x. And then 2 times a negative 3 is a negative 6. These two can be combined. This is 18x squared plus 3x minus 6. Oh, God, I hope this is the answer. Wait, let me look. Is this the answer in the back? Can somebody tell me? Because there's, it looks like I might be able to do something else. I'm going to leave it like this for now.
That's the answer.
Oh, good, good. I was thinking maybe we have to try to factor it or something, but they just want us to show you that you multiply the two together and then you're done. So this is the answer. Now, state the domain. Okay, that's going to be a hard one. So we're going to state the domain for this. We're not doing number 8. We're doing number 7. So the domain, if you remember domain for square roots, the inside has to be greater than or equal to 0. The inside of the radical has to be, remember, it has to be positive or 0. So now we have to go through the process of factoring. A 3 factors out of each one of these, a GCF. So I'm going to factor a 3 out. When I divide each by 3, I get 6x squared plus x minus 2. Oh, no. I'm going to erase the top part. I'll give you a second if you need the right, because I'm going to erase the top part and scroll this up. But I'll give you a second to write the top part down. If anybody needs to write this down, write it down now. So I'm getting ready to erase that. This is the answer for multiplying those two together. But now we have to find the domain, and that's what we're doing down here. I don't think this domain problem is on the test, but I need to make sure I do it at least. So let's see if we can do it. So I am going to, I'm going to erase that and bring this up. Wait, I don't know what I'm going to do. Let me just erase this part. So this is where we're at. 3 times 6x squared plus x minus 2 is greater than or equal to 0. If I divide both sides by 3, that 3 just goes away. 6x squared plus x minus 2 is greater than or equal to 0. Do you see 0 divided by 3 is 0? We have to try to factor this. And we have to use the AC method because there's a number other than 1 in front of the x squared. AC method is 6 times 2. 6 times 2 is 12. So 1 times 12, 2 times 6, 3 times 4. Those are all the things that multiply together to get 12. Which one gives me a positive 1, a plus 4, and a minus 3? We have to split the middle, so I'm going through this kind of quick because we've done this factoring before. A minus 3x and a plus 4x. We have to use the x. Minus 2 and 6x squared. So then completing the factoring, group the first 2. Group the second 2, make sure there's a plus sign between it, and factor the GCF out of each. The GCF out of this first one looks like a 3 factors out of there and an x. If I divide each by 3x, I get 2x minus 1. 2 factors out of this one, I get plus 2, and then I get 4 divided by 2 is 2x. 2 divided by 2 is minus 1. Then we factor out the parentheses since it's the same. I'm going to put it over here, 2x minus 1. Whatever's left over, the 3x plus 2 is right here. And we say this is greater than or equal to 0. So then we set the 0 multiply rule. This is, like I said, this domain problem is tough. Is greater than or equal to 0. 3x plus 2 is greater than or equal to 0. And then solve for x. Add 1. I'm left with 2x is greater than or equal to 1. Then divide by 2. Divide by 2, divide by 2, and x is greater than or equal to 1/2. Here, I'm going to take the 2 over and the 3 over. This is a minus 2, minus 2. And then I'm going to divide by 3. Divide by 3, divide by 3. And x is greater than or equal to negative 2/3. All right, so this is our answer for the domain, but we have to graph this to truly understand it. I'm going to leave myself some room. I'm going to erase this. We have to graph it to truly understand this. Here's 0, here's 1/2, and here's a negative 2/3. X is greater than or equal to negative 2/3. X is greater than or equal to 1/2. Now, the domain for this problem is where they both meet, where both of these parts meet for square. Do you see? Right here. So the answer for this domain is x has to be greater than or equal to 1/2. Do you see? Where both of the graphs combine, they both start off at I mean, they both touch 1/2, and then they go to infinity, and that's how you would write it. X is greater than 1/2. Or, I mean, interval notation, you'd put 1/2, and it equals 1/2 because of the bracket. It equals 1/2, so we put a bracket, and it goes to infinity. So this is the domain. Either one of these is fine. Hopefully the back of the book has that as your answer, between 1/2 and infinity. Because let's just say you put 0 in here. If I put 0 in here, I get the square root of -3, and you can't have the square root of a negative number. Do you see? 0 is part of this, but it's not part. You can put 0 here, I get a square root of 2. But that works for this one, but it doesn't work for this one. Everything works for both of them because both lines are here starting at 1/2 to infinity. So that's the domain for number 8. So that, I mean, look at that. That's just factoring and finding the domain. The actual multiplying the two together was the easy part. Number 8. F divided by G. Another way of writing F divided by G is this: F of X divided by G of X. We're just plugging X in. Square root of 9x minus 4. And on the bottom, we have x squared minus 9. That's the answer. There's nothing I can do with it. Find this. That's the answer. The hard part, once again, is finding the domain. The hard part is finding the domain. And we're going to have to graph it. Look at the bottom. There are two numbers that x cannot equal. Can you tell, on looking at the bottom, what can x not equal? Can anybody look at the bottom and just tell me what x cannot equal? What makes the bottom?
9.
Yeah. Well, not 9. 9 squared is 81. You have the
3
right
squared.
Yeah.
3.
What x cannot equal 3. Do you see? 3 squared is 9. 9 minus 9 is 0. But there's one more. X cannot equal -3. And a way to do that is you can actually do this. X squared minus 9 cannot equal 0. Let's take the 9 to the other side by adding 9 to both sides. And then if it's a square, you square root both sides. Square root square is x. And the square root of 9 is 3. And don't forget, when you take the square root of a square, you get two answers, plus or minus 3. These are two things x cannot equal, because we use that square root property where you get the square root by itself, the square by itself, and then square root both sides. And when you square root both sides, you get two answers, a plus or minus. Now we still have to find the domain for the top part. Remember, the inside of a square root has to be greater than or equal to 0. So I'm going to take the 7 over to the other side. 9x is greater than or equal to 7, and divide by 9. So x is greater than or equal to 7 over 9. Let's graph this. Here's 0, here's -3, here's 3. There's -3, here's 3. X can't equal those things, but x equals everything greater than 7 over 9. 7 over 9 is less than 1. Here's 1, so here's 7 over 9. So 7 over 9 looks like this. Just to let you know, the bottom, x cannot equal these two things, but it equals everything else on the bottom. You can do any other number. So where do these two graphs combine It starts right here at 7/9. And then it's the same up until we get to 3. But then it starts up again on the other side of 3 and goes all the way to infinity. So this is the way to write the domain for this problem. You got to do the domain for the top and the domain for the bottom. Look on the graph for each one and see where they combine. The bottom one, x cannot equal these numbers, but they equal everything else. That's why, and on the top, this is what x equals. And they only correspond right up to 3, from 7/9 to 3, then on the other side of 3, all the way to infinity. So that's those two domains, number 7 and 8, are really tough. We'll know when we look at the review. I already have the review video on here, I think, but I'll verify that next week for the review video. But hopefully there's not any domains like number 7 and 8. Those are tough ones. But definitely give it a try. You probably have something like that on the homework. If you guys are doing pretty good with the homeworks and all, so maybe that's why you're doing so well with the tests. You'd be surprised how many classes I have and students that just refuse to do homework, and then they end up if you don't do the homework, how are you going to do the tests? Okay, number 9. Look at this graph. It's function f. And this graph is function g, okay? Remember what this means. This says find f and then find g, where x is 3. Now, when I find f of 3, when I find this, what am I finding? Remember, this is the x value. So when it says find f with x equals 3, what am I looking for? I know it's a really vague question and it doesn't kind of not, but if x is 3, I'm looking for y. Do you see that? Remember, f of 3 equals y. Do you see? This is the x value. This is the y value. The answer is the y value. So I'm looking for what y equals when x is 3. Over here on function f, look where x is 3. 1, 2, 3. This is x3. That is 3. Can somebody tell me what y equals at x equals 3? And by the way, when I say x is 3 in the function f, I'm only talking about the graph. The graph is the actual function. So at x equals 3, can somebody tell me what the y equals on this graph?
1.
Yes. This is x3. You have to go, this is x3. You got to go up or down till you hit the graph. We hit the graph right here. This is x3. Y is 1. Do you see? Y is 1. So the answer to f3 is just 1. The answer is the y value. When we find f3, the answer is the y value. Now we have to find g3. 1, 2, 3. Here's g3. Go up or down till I hit my graph. My graph is right here. This coordinate is x3. Y is 1, 2, 3, 4. Y is 4. That's the answer. 4. So we have to add these two functions, these two answers together. 1 and 4 is 5, and that's my answer. I take this y answer, I take this y answer and I add them together. 1 and 4 is 5. Everybody see that? Doesn't seem too bad. We have an x, we have to find the y. Sometimes people get really confused on that function, the way it's, the nomenclature, the way it's formatted, but it's really not that bad. As long as you remember f of x equals y. Here's the x value, and this is the y value. When you have this, then the answer is the y value. Number 10. Uh-oh, we're in trouble now. This is easy. I'm telling you, this is easy. But we're in big trouble. We have two functions, f and g. Anybody know what this is? What is f and g doing? What is that circle in there? A lot of people think it's multiply. It's not multiply. This circle is called a composite. Composite. I think the homework might even say composition. So they call it a composite or a composition. Okay, so this is a really, it's easy. It's easy, but you have to pay attention to the rule. Composite means step 1, find answer to the right side of the composite. In other words, the right side is this right here. This is the stuff on the right side. I need to find this first. G of -6. So you always take the right side first. G of -6. Find the answer, and when we say answer, we're talking about finding the y value or whatever the answer is. So here's G. I have to put -9 x squared minus 2x plus 1, and I am going to plug in -6. And you have to plug this -6 into G because it says that you do the right side first. So I'm plugging -6 into this G function. Everywhere there's an X, I plug -6. And I'm gonna put this in my calculator because I have no idea. -9 parentheses, -6 squared minus 2 parentheses, -6 plus 1. And I think I get this crazy answer, 311. Anybody else get that? Anybody else?
That's what I got.
Okay,
I got that.
perfect. So that's step 1. Step 2, take answer from step 1, plug into x value of left function. So in other words, the left function is f. The left function is f. And we're going to plug -311 into it. Take the answer. This was the answer to the first part from step 1. Answer to step 1. Take the answer in step 1 and plug it into the x value of the left function. The left function is f. Well, let's write down the left function now. 9 times x plus 2. We are going to plug in negative 311 and find the answer. 9 parentheses negative 311 close parentheses plus 2 is negative 2797, and that is final answer. Do you see step 2 was take the answer from step 1, plug it in the x value of the left function to get the answer. The answer is 2797. Another way of writing this would be the composite of f and g. When you plug negative 6 into the first function, you get negative 2797. This is not the answer to the problem. It's answer to step 1, but then you have to plug it into the left function, and this is the answer to the whole function. If you look in the back, hopefully that is the answer, minus 2797. So the composite, we take the right function, find the answer, then we plug that answer into the left function. All right, so we're going to try another one. Number 11. This first thing I notice, it's a composite. When I have a composite, step 1, take and find the right function. Find f negative 9 into the x. Well, here's f. We're going to plug in negative 8 parentheses minus 9. And we're going to plug this into the x value. And when you do that, you should get negative 81. This is the answer to step 1.
I got 63.
Oh, you're absolutely right. Negative 8 times negative 9 is a positive 72. 72 minus 9 is 63. Thank you. See, one of the negative signs I didn't see. Thank you. See, I need somebody to speak up. You get 1 million bonus points for that. Take your million bonus points, go to Starbucks and tell them Mr. Troutman gave you a million bonus points. See if they give you a free cup of coffee. Okay, so this is the answer to step 1. Step 2, take this answer and plug it into the left function, g. So here's g. We're going to plug it in to the g function. We're plugging 63 into the x value of the g function. Well, here's the g function. Negative 9x squared minus 8x plus 5. We're plugging 63 in there. And then putting that in the calculator. Somebody better check my work again. See, the last one I didn't put it in the calculator. Or maybe I did. I just forgot the negative. This time I get, why do they have such large numbers? This. Somebody verify. Did anybody else get that?
I got 3,500 to 35,222. 963 square minus 8.
Negative. It's -9, right? -9.
Oh, I didn't put the negative. Yeah, I did put the negative. I'm sorry.
Okay. All right.
I'm gonna try it again.
All right. Did anybody else try it? Everybody else is sleeping.
I got
Watching.
the same as you.
Okay, good. So that is the answer. So composite, you take the right function with the number, find the answer. Once you have that number, you're plugging that into the x of the left function. And then once you find that answer, that is your answer. All right, one more, I think. Did I say there's 12 or 13? I almost forget. No, there's we have 13 also. Good. 12 and 13. All right. So number 12. So I'm going to give you a second and see what you get for part 1 of number 12. Step 1. I'll give you a second. I'm not going to do it. Just see what you get for step 1. Type it into the chat box if you get something for step 1. I think I got that. There we go. Everybody else is sleeping. So first thing you need to do is find this. And here's function f. Function f is x minus 1 divided by 3. Function f when we plug 10 into it. So we are going to plug 10 into the x value here. 10 minus 1 is 9. 9 divided by 3 is 3. That's the answer to step 1. I now need to take this answer 3 and plug it into the g function. Three goes into the g function. The answer goes in the g function. The g function is this right here, 2x plus 3. And we're going to plug the 3 into here and do the math. 2 times 3 is 6. 6 plus 3 is 9. And that is our answer, our final answer. Is everybody okay with this stuff so far? I mean, you really don't learn it until you do the homework. You really don't learn it until you do the homework. I think on Monday, next Monday, I think I'm going to have a quiz. Maybe because I won't be doing so many lectures, maybe I'll have more little quick quizzes in class. Yes. Homework, please. The homework gets it down at least. If you wait to do this homework, let's say you wait to do this homework Sunday, oh, you'll probably be sitting there saying, I don't know what happened. I mean, it looks so easy when the teacher does it sometimes. Maybe not all the time, but sometimes. And then when you try to do it at home, anybody goes, what just happened? I have no, every day, yes. I have no idea what he did. I kind of thought I was following him when we were in class. Now I have no idea. Yes. That's why the videos are there, but I mean, it's tough watching another 1 hour video. But it does, if you have the time, the videos do help again, because if you watch it the second, the first time you're in class and going through it, then you watch it again, it really solidifies that you are starting to learn this. All right, so we're doing the same steps for this problem. It doesn't look like the other problems, but we're doing the same steps. Step 1, find the answer to the function on the right. What does the 9 represent? Can somebody tell me what the 9 represents?
X.
Yes, it's the x value. I just want to make sure. Don't forget, f of x equals y. So this is the x value. This is the answer. The answer is the y value. So look at function f. Look, this is function f. This is function g. This right here is function f. When x is 9, right here, x is 9, what does y equal? 10. Do you see f of x equals y? Do you see? This is the x value. The answer is 10. The answer to this is 10. This is the answer to step 1. Find the answer when x equals 9. The answer is 10. We're going to take 10 and plug it into the g, into the left function. Can somebody tell me what the answer is when I plug 10 into the g function? This is the g function. What's the answer?
19.
Yes. Do you see we're plugging 10? Now we got the answer here. Now we're plugging that 10 into the g function. Well, look for x10 right there. So the answer to this is 19. This is the final answer. This is the answer we're looking for. What this was the answer to step 1. When you plug 9 in, you get 10 as an answer. Then you have to plug this 10 into the x value of the left function, which is g. I'm going to do one more. I'm going to do one more for you guys before we go. I want to make sure we get this. I want to see who gets the final answer to this. Do you see this is G composite F9? I want you to find F composite G. Nine. Let's see what, type in, find the entire answer, the final answer for this. I'll give you a second and then I'll do it. Oh, excuse me, somebody did it way too fast. But she may be wrong. Who knows? We're looking for this, not this one. We're looking for this one here. Does everybody believe her? She typed that in way too fast. I think she just typed a number in. So don't trust her. Oh, Amanda trusts her. Okay, there we go. So first we're finding g when x is 9. Here's function g. X is 9. The answer is 20. This answer is 20. We're going to plug 20 into f and find the answer. So here's function f. We're plugging 20 into it. The answer when you've plugged 20 into f is 51, and that is the final answer. It's the Starbucks. There you go. Yeah, you answered that question way too fast. Did you have the back of the book open? All right. That's it for the day. Let me hit stop record.